Hey, I want to go ahead and finish 6.2 with y'all. So I've given several of y'all the paperwork that went with 6.2. So we're going to go to example 6. I'm just going to write it on my paper. You can write it on yours if you got it from me whenever we were open the other day. So the example is, when designing an environment, one common criterion is to use a design that accommodates 95% of the population. What aircraft ceiling height will allow 95% of the men standing without bumping their heads? That is, find the 95th percentile of the heights of men. Assume that heights of men are normally distributed with a mean of 69.5 inches and standard deviation of 2.4. Okay, so we have the mean is 69.5 inches and standard deviation is 2.4. So we have 69.5 and we want it to accommodate 95%. So this would be the area is 0.95 for all of this. We want area where it's 0.95%. So we need to find X. We first need to find out what that area is. So if the area equals 0.95, what is the z-score? So we can use this down here. 0.95 is actually 1.645. So 1.645. So this was on the positive z-scores. And I want in the body 0.95. But see how there's a dot there in between 0.9495 and 0.9505? So that means I'm going to follow that down and over. So that's 1.645. So that is my z. So then I use that formula, x equals the mean plus z times the standard deviation, to find out what the actual height is here, because that's what we want to find out. What is the height that will accommodate 95%? So x equals 69.5 plus 1.645 times 2.4. I'm not sure where my calculator is right now. I haven't seen it lately. So whenever we do that, we get that x equals 73.445. So that means that the height is about height to accommodate 95% of men is about 73.4 inches. We could also use the calculator to do this. So you have mu is 69.5. We have that our z-score is, this is whenever you use your inverse, 1.645, and then we plug in the calculator. Let me see if I can find my calculator. Working from home can be chaotic because I don't know where anything is. I just found it though. Okay, so quit, clear. So bars, inverse norm, area is 0.95, mu is 69.5. Then our standard deviation is 2.4. So using the calculator, we got 73.4 also. So no matter which way you do it, you can get the same. Okay, let's go on to example 7. Okay, so they're designing the placement of CD player in a new model car. They want to consider the forward grip reach. The driver must not move his or her body in any way that could be distracting or dangerous. Design engineers decided that the CD player should be placed so that it is within the forward grip of 95% of women. Women have a forward grip that reaches, the mean is 27 inches, standard deviation is 1.3. Find the forward grip reach that separates the longest 95% from the others. So, isn't this interesting how this is taken into account whenever they build cars? So, let's see, example 7. So, I'm going to write down the important information. Mu is 100. Standard deviation is 1.5. So we have our standard deviation. It wasn't 100. I'm looking at the wrong one. Sorry. This was supposed to be mean 27. Standard deviation is 1.3. I was looking at example 8 for some reason. So this is 27, not 2.7, 27. And we want the 95%. We don't know what this is, but we know that the area is 0.95%. So 95% is majority of women will be able to be able to reach without moving. So we need to find our z-score. So if it's 95%, our z-score, again, it's the same thing. It's the 1.645 for 95% of the area. So this is where we want to find what x is. X actually goes with this. So we have mu plus z times standard deviation. So we do 27 plus parentheses 1.645 times 1.3 to get what x is. So when we plug it in, so 27 plus parentheses 1.645 times 1.3. 29.139. And then we can use the inverse norm. And we have 95%. We have 27 and 1.3. Sorry. Is 29.138. So, same thing. Okay, let's do our last example for this. And then the rest of it is just how to use the calculator, but we've been doing the calculator all along. So the last example is example 8. Some educators argue that all students are served better if they are separated into groups according to their abilities. Assume that students are to be separated into groups with IQ scores in the bottom 30%, a student group of IQ scores in the middle 40, and then a third group with IQ scores in the top 30. The scale yields the IQ score obtained through a test, and the scores are normally distributed. 100, standard deviation of 15. Find how it's separated into the 3 groups. So we have, and it says we want to find out what that bottom 30 is. So this is going to be 0.3. And then we want the middle 40. So we have 30 here. So we want the middle 40 right here. And then this is right there. And then the top 30. So the area here is going to be 0.3. So let's find out what this number is using area of 0.3. So we need to use our, it's going to be a negative z-score because it is below the mu. So we are going to look for 0.3 0.3 in the body. Looks like it's right around here. So we need to know which one's closer. And it's actually this one. So it's negative 0.5 and then go up to 2. Negative 0.52. Okay, so then to find x, we would do mu plus c times that. X equals, oh, I need to plug in the numbers. Okay. 100 plus negative 0.52 times 15. Oh, I messed up there. Should have put 100. There we go, 92.2. Yeah. All right, so this is 92.2 is the IQ score. Okay, so now we need to go up and find out what this is. So we're only going to have two numbers, really. So below 92.2 is 30%. And then this is between 92.2 and whatever that is. So we actually need to look at what this whole area is right here. If that's 0.4, then the whole area is 0.7. So we're going to say that the area is 0.7. So we need to find our z-score. So it's on the positive one. So 0.7. Okay, so it's in between these two. Which one's closer? Say that this one's closer, 0.6985. Can you see that? There we go. So that's actually negative 0.52, which that makes sense. It's positive this time, sorry. 0.52. And the reason why they're the same is because you have your 0.3, your bottom 0.3 and your top 0.3. So they're going to have the same z-score because they're the same distance away from the mean. So to get your x, you do mu plus z times x equals 100 plus 0.52 times 15. Use the same one. And then should take off that negative. So x equals 107.8. So then this is 107. Okay, so the three groups. First group is your bottom 30%. And that is where x has to be less than or equal to 92.2. Second group is your middle 40. That's whenever x is between the 92.2 and the 107.8. And then your third group is your top 30%. That is when x is greater than or equal to 92.2. So those are your three groups. All right, so that finishes 6.2. So you'll be able to finish those notes and then do the My Math Lab assignment.